Okay. Going twice, right? Okay, guys. So I hope you are here to come to learn something about MySQL performance optimization. Yeah, I don't see any. Yes, yeah. Okay, that's what you need to do, right? Okay, and there is one more bonus. I want you guys to like me. So I brought you two things. First, there are some T-shirts you can take after Tom, which look exactly like this, right? And by the way, this is not a squirrel. This is mongoose. And you know why it's mongoose? Because the Toku MX is our replacement for MongoDB, right? MongoDB, mongoose, that sounds cool, right? Okay, but that's not what we're going to talk about, right? Yes, and besides T-shirts, I also got some Percona stickers if somebody is interested to waste your laptops a little bit more. So in this presentation, we're going to talk about the practical approach for performance optimization. We're going to talk about the MySQL, but a lot of it will actually apply to some other database systems too. We'll discuss the practical performance optimization tips and then tools, how to approach that. The first thing to know is that the MySQL performance doesn't matter, as really any database performance, right? Because what we really care is the application performance, which is using that database, right? In this case, that is what your boss cares about, your users care about, the application performance which they're using. And what is important in this case is the application performance always matters. In so many cases, I would come to people and we talk in the Ace, oh, this application functions doesn't really matter. And I would ask them, okay, so you wouldn't mind if it runs for 3 months? Oh, of course I would. Aha. So performance does matter for you, right? You just think, what if it's not something which have to be running sub-millisecond, right, or sub-second, it's not performance critical, which is a very wrong way to think about that, because as an application grows, load grows, data size grows, it's very typical for your things which have been taking a second to take a lot longer time, right, and kind of became performance critical in your understanding. So the takeaway here is simple, right? First, with the performance problems you have with your application, it may not be MySQL, right? In a number of cases, or I would say in many cases, I see developers, they like to blame the database. That is a very big thing that developers like to do. And I would often ask them, okay, guys, so you are telling me that's a database. Why do you think so? Well, because it was database last time we had a performance problem. Well, not very important, right thing, right? And especially in the modern world, when they often write the application as a set of microservices which talk to each other, when they're using external APIs aggressively, there are much more things in a database which can go wrong, right? I remember one of the cases when they had a huge spike of customers which are getting a lot of problems, and they would at the same day, and they would think that is a MySQL problem. What that actually was a case where was a Facebook API was having some problems, right? And they use it aggressively in the application. Now, another important thing to know is even if a MySQL is really a problem and there is a bottleneck out there, your solution may not be just fixing a MySQL. It may be something else, using some other tools, right? And I think what is amazing and wonderful in the open source community is what through years there is a lot of great tools to work with the data have been created. It is not like, let's say, this narrow Oracle approach, right? Then if you have a data, you store it in an Oracle database server, right? Or Microsoft SQL Server, same approach, right? If it's data, it goes to Microsoft SQL Server because that is essentially our only data store, right? We have a lot of choice those days, and MySQL is good for certain things, not for others. Some other technologies may be more interesting, maybe better, and you should be using right tools for the right job. For example, for years, right, even kind of going back like 10 years now, Memcache has been used to supplement MySQL, right, by acting as a data cache. The next thing I want to talk is, what do we mean by the performance, right? Well, when I say performance, what most of us means is exactly response time, right? Because that is, again, what our boss and our users care. How does application respond to us? We are all pretty much egocentric, right? If things are fast for me, I'm happy and I think application works quite fast, right? If not, then I don't care, right? I think it's interesting story in this case was actually about the Oracle. One of the, and you know, like an Oracle is much more kind of centralized Oracle kind of office structure. And MySQL organization was like very distributed one. They would move to the Oracle support interface, right? And some of the guys working out of China, right, or Turkey, you know, sometimes, hey, you know what? Your web interface is horrendous, right? It sucks. It's so slow. It takes me 30 seconds actually to do stuff I typically have been taking for 3 seconds. And say, hey, we're sitting out there in our office in Redwood Shores, and from our office, it all responds in microseconds, right? I mean, we don't see what the problem is, right? So I was just wanted to illustrate that, what we need to be really looking at our experience when we talk about performance. Anyway, so it is a response time, application response time for specific users. What kind of other issues we often have to be thinking about when we are looking at a performance as a kind of a larger area? One is stability, right? We want the systems to be behaving with a decent performance all the time, night and day, for different users, right? Sometimes you may have a good performance during the day, but then during the night, for example, you have a backup job, right? And during backup job, things may go wrong. So you may have performance decent in some cases, but pretty unstable. Scalability, that is another factor. Typically, for a lot of applications, we see them grow. We want them to grow, right? We want our application to grow from 10,000 users to 10 million users, right? And then go from there. So that means we have to have application scaling. That means you have to look not only application at how it behaves today, right? But also how things are going to scale in the future with larger database, more concurrent users, and so on and so forth. Another one is efficiency, which is also quite important, right? Because certain solutions allow us to reach pretty good performance, but that can be not very efficient at the high cost. Like Hadoop ecosystem, for example, for years have been known is being able to achieve a very good performance, right? You want to organize to process so many petabytes of data, well, just spin up 10,000 servers, right? And it will work pretty well for you, right? But it won't be very efficient in terms of data algorithm by scanning a lot of his data, right? Not being efficient, and whatever you care about the kind of money, right, or being green and not using a lot of power, it still goes to approximately the same stuff. Now, when I speak about the scalability, we have to be thinking about a couple of things, right? We have to be thinking how it scales about the load. We may be getting more users, data size, as well as what I will call the infrastructure, right? In our case, we may have different choices in terms of what kind of infrastructure we're going to use for our systems. We may be going what's called scaling up. Now I run my application on some micro instance on Amazon, but then I'm going to take it and have a server with 64 cores, half a terabyte of memory, and flash, right? That's scaling up, getting some really big iron. And for many applications, that can be quite different, quite decent solution, right? For others, we can say, no, I actually don't want to do that. I want to what's called kind of scale out, right? Keep maybe number of boxes of kind of not so powerful, but many of them, right? Or it's kind of a combination of thereof. Now, what is interesting in terms of talking about scalability in terms of data, and load is what in a lot of cases you have to scale for both, right? As our applications grows, often you'll have to process much larger amount of queries on the larger data sets. So when we talk about performance, right, if you would get some people who only focus about performance, they will provide you solutions which may not be practical based on some other dimensions, right? One is security, right? Security often requires like an extra code, extra process, which generally slow things down, right? I haven't seen anybody tell me, oh, you know, we'll get it more secure, and because of that, it will run 10 times faster, right? Probably it's going to be other way around. Manageability as well, right? Have you guys seen the most optimal code? That's probably would be something, you know, like assembly hacks, right? Which would be impossible to maintain, right? And the same applies to the database as well. It could be like SQL magic, impossible support, right? Or some other tricks. If you want to, that's what we want to balance, because we want our code to be maintainable. We often want to be compatible with different versions, right, or other versions. Compliant. In a lot of cases, we find in a number of industries like HIPAA or PCI compliance again. So that all requires us like to log all kind of crap, right, or things, right? And also ease of use by developers, right? Because often we can say, hey, to scale this feature, we want you to do X, Y, and Z, but developers may not really want it. And as I talk about some features, those concepts they do. Now, another thing about the performance optimization is I think it's very important to know where to stop, right? There is no system out there where you can say, that's it. It is the most optimal out there. There is nothing else you can do, right? There's always yet another thing you could optimize. But the thing is, at a certain point, there is no really value for a user, right, or a business doing that optimizes. And also, every kind of next several percent becomes increasingly more and more expensive, right? First, you can just grab those low-hanging fruits, easy, but then you have to do something more expensive. So a lot of what we spoke before was kind of about the, I would say, how to think about performance, right? And what kind of things to consider. But now let's look about our database, MySQL in this example, and think what exactly that database does. And it does quite simple things, right? It runs selects, insert, updates, all kind of query. And really, what we care about is how quickly MySQL is going to respond to those kind of query and throw it. If you look at that as a black box, that is essentially it, right? There is nothing more to that. Now, if you think about the performance optimization, what we often look with MySQL is we want to make queries run faster as a primary goal, right? Then we also would, I would say, often have some like a secondary goals, how we can do that while using less resources, right, and scaling better. Now, if you think about that, there are a couple of approaches we would use for optimization. One is, which I would say, the transaction focused. Let's say you have an application and somebody calls you and say, hey, you know what, we have this kind of, let's say, payroll which has been running for a week and it didn't complete yet still. That's not good. Can you help us and optimize that specific application transaction? Everything else may be running well, right, or we may not care about. And in this case, what we would do? Well, we'll go to that process, we'll figure out what queries it runs and why they're running slow, optimize them, or maybe something else is kind of locking, right, or prevents them from processing faster for due to other reason, right? And we deal with that. But it becomes kind of very, very focused on the on those queries. Another approach is we can say, hey, you know what? We have a server which is kind of loaded pretty high, and everything is kind of becomes sluggish at the time of a peak load. What we can do? Well, in this case, we can take a look at the queries the server is running, which are the most frequent, which are running the most resources, and we prioritize them and optimize them, right? That's how you do. But before you kind of really become obsessed about the queries and trying to optimize them, I think you should ask a question: are those right queries to begin with, right? Because I would tell you, majority applications, when they come to the customer and ask them, let's enable the query log file, and then let's go hit the page, see what queries are running, and then I'll go to ask you, why are you running this query? In almost all cases, we're going to find the queries which are just a waste. Somebody say, oh, we are just initializing this object, but this feature is not really used in this case, so it's kind of random, right? Oh, we are running that query 5 times for the same page. Oh, just because, well, we didn't think about the cache on that, right? There is going to be a lot of waste, most likely. And it is a very good idea to get rid of those queries, right? Or maybe get rid of by eliminating them completely fair waste, or maybe moving them to something else, for example, by caching results in memcache or Redis or something. What we can also do is think how we can make those queries to do less work, right? And by less work, what I mean is just run queries which don't have to return as much data, right? Or do as heavy aggregations or stuff like that. So when we look at the queries, there are a few things you want to consider. First is, do not look at the average only, right? Because average is kind of very misleading. Problems almost never happen at the average. But you also don't want to look at complete outliers, because databases, most of them, what they want to use, and they're not designed as to be kind of really hard real-time systems. And there are going to be some outliers for whatever reason, right? And trying to say, why is that primary key update took 5 seconds, one of a 10 million executions, right? You can spend a lot of time trying to catch that, and it's actually quite irrelevant, right? Because it's so rare, it doesn't matter. What you want to focus on something like 99 percentile response time, right, or something where you really look at the heavy kind of not quite worst scenario, but bad enough scenario, right? So that you want to look at the trends over time, weekly, daily, monthly cycles, right? I mentioned backups as a very common issue, right? Oh, we're running backups and everything grinds to halt during the night. Or it could be some weekly cycles where we do some bad jobs to, I don't know, let's say, delete the old data, which again slows down completely. And then you also want to think about the future performance. How is your data size change happening, and how it's going to impact your performance? Or cardinality, right? Because as a cardinality between data change, queries may be taking much more, have to do much more work to run. So a few tips about queries. First is do less queries, right? Because latency is overhead, and because for each query there is some processing time involved. And I would say especially some new developers can really do ridiculous things. I've seen, for example, people to draw a table, we would essentially run the query for each freaking cell on the table instead of just doing one select, right? Bad idea. Now, somebody wants to guess how many queries I've seen max per page, single page, how many queries? Anybody wants to guess? Come on, guys, wake up. The lunch was kind of 2 hours ago. 100. Oh, come on, 100. It's actually is a decent average. Well, I was at I saw about 60,000 queries, right? For a single page, right? Yeah, and that's kind of like for some insurance company. Well, and then a friend of mine, he walked to another customer, and he saw more than 100,000 queries a page, right? Well, so I mean, in certain cases, those numbers can be truly ridiculous, right? Some people do absolutely stupid things. We want to read or modify less data, like less rows we touch, less columns is better. You want to process less data on the fly, because processing data on the fly over and over again is expensive, like running large aggregates. Having something like a summary or cache tables, right, which have data pre-baked and ready to use can be much more efficient. Another thing I like to look at is how much data is being traversed, kind of touched in database versus actually sent to the client, right? So how much data that client used. In MySQL, we can essentially look at the rows examined and rows sent with a kind of two things which are printed in this log query log. And if you have a number, less than 10, then that's pretty cool, right? If you are having a number like 100, 1,000, then chances are your query is not using index as well, right? Or doing some massive wasteful aggregate and so on and so forth. Another thing to think about is how much data is sent versus being actually used for an app to do whatever it has to do. In so many cases, you are fetching much more columns than you need, or you even add more tables to the join, which then you end up not touching any columns from, right? Or I've seen people just running select, fetching all of the data from the table, right, and then using first 5 rows and then throwing away the rest. That is not a good idea. And frankly, this is a challenge because we can look at the automated tools to see how many data was traversed versus sent, but we cannot automatically see how much data was actually used by the application. Schema. Now, schema really is a very key thing for performance. And I think what is important to do is to look at the schema and the queries together, right? Because really, in the practice, often amount of what kind of access and operations you're going to do often would impact how your schema is going to look like, right? Now, when we have optimizing the system and we're looking at the schema improvements, there are essentially two things which you can do. One is a minor schema changes, something like, hey, why don't we change the index structure, which are pretty cheap, pretty simple. And other what I would call data architecture. Often you'll say, oh my gosh, what the hell are you doing? For your application, you should have structured your data completely different ways, right? And now it is going to make it quite expensive to change that, right? So when it comes to the data architecture, the best way to identify that and make decisions is probably 6 months ago, right? When you just started applying on this application. A few things about the schema indexing, right? And there are certain links out there which I will show, which I gave a much more in-depth presentation of the topics. Design schema which is focused on your data access and queries, right? Do not, I mean, if you just take a textbook schema based on ER diagram or whatever, it's unlikely will perform very well at the scale. Also think about various techniques which database provide for kind of a physical performance optimization. Partitioning, sharding, normalizing or denormalizing data, right, depending on whatever you need. Use current indexes, stuff like that. Okay, a few other things which matter. We spoke about the infrastructure, where you're exactly running that. In a lot of cases, going from a very small box to just something a lot more powerful, maybe the best return on investment, doesn't require a lot of time of development team. Operating system and configuration, right? If you're using a decent operating system, properly configured, that would be good. MySQL version, MySQL configuration. Now, in terms of a process, what we try to observe is I put it in essentially 3 buckets, right? One is low-hanging fruit, something we can do in hours or maybe days, right? MySQL configuration, operating system settings, indexing, maybe introduce some caching. These are all very easy, right? Medium level is something of a more big infrastructure piece, right? Like hardware, moving to the cloud or from the cloud, doing a major operation system upgrade or upgrade of MySQL version. These are much more involved, right? Typically some testing involved and planning. So I would say that goes kind of days, maybe to weeks, right? And then with the hardest changes, which are the most expensive ones, which is a major schema changes, right? Because if you rewrite your schema completely, you'll have to do a lot of application changes as well. And application architecture changes in general, right? If you have to go ahead and rewrite all the way how your application works with data, that's also going to be the most expensive, right? And what we want to look in this case is generally to see which of those approaches really are relevant in your case, right? And maybe you just can do with minor changes. Infrastructure, scaling up, scaling out. I mentioned that. In terms of using, okay, anybody runs in the cloud those days? Okay. Anybody runs in private cloud, virtualized environment? Okay. Anybody runs on bare metal? Okay. Hardware, right? So if you look at the hardware for MySQL, these are four most important things you want to focus: CPU, memory, disk, network, right? For CPU, I think those days, Intel essentially owns the market, right? We're no more speaking about what CPU vendor to pick, right? Which of the CPUs to use. With MySQL, 2 sockets for pretty powerful servers is what it's used, right? And that kind of can get us pretty good amount of cores and threads those days. So you really need to do more. Generally, MySQL runs some of the operations still in the single thread, right? Like if you run some complicated query, it will use only one CPU one thread and one CPU core only. So for MySQL, in many applications, faster cores are more important than many cores, right? It's kind of at least more sure bet. I mean, I know many vendors try to sell you, oh, why don't you buy this CPU which has half a frequency but has twice as much cores? Not a good choice for MySQL. Memory. Main purpose of the memory in MySQL is a cache, right? And assuming your database is large, you want to really get a lot of memory. At the same time, if your database is small, then getting memory much, much more than your database size doesn't really help, besides kind of future-proofing your environment. And what you often want to look at the memory together with the storage to see what is more optimal. This is kind of an interesting graph, right, which shows different kind of storage. And here we are looking at the slow storage, kind of mid-grade SSD, and pretty high-performance SSD, Fusion IO, right? And you guys can see if your database doesn't fit in memory well at all, right? There is a very, very heavy IO, then investing kind of in the storage makes sense, right? Because you can, in this case, like here, for example, you can get, let's say, going from 2 gigabytes to 6. You would get much more from using the high-performance storage than from tripling your amount of memory, right? And there are cases like that, obviously, on the larger side as well, right? There are some workloads where you may do much better than in having high-performance storage than having half a terabyte of memory instead of, for example, 128 gigs, right? While if the data fits in memory well, then you can see all of those kind of storage types, they sort of coalesce together, right? If the data fits in memory completely, then there are almost no difference in performance, right? So it's good to understand that and to use that as a guide to planning what is better to invest, storage and memory, right? unless you obviously can have it both, right? In this case, just get it both. In terms of storage, there are essentially a few types of storage you would have. In my opinion, for OLTP workload, the disk is dead. You want to be using flash. It just depends what kind of flash you want to be using, right? And there are a few times. There are also a number of ways how you may be able to think about the availability for that storage, which may be using hardware rates, software rate on file system like ZFS, and also note what if you're using high performance or enterprise solid state storage, then it essentially has a RAID internal in the card, right? So you may not really need that. Network. Now, in terms of network, think about the distance and number of hops, right, as the biggest contributors to latency. I remember somebody saying to me, "Oh, why is this so slow? I have a gigabit connection here." Okay, gigabit connection between what? Well, we have a 2 data center on the East Coast and on the West Coast, right? Hey, you know what? Simply the distance, in this case, is what's going to be the dominating factor in the latency, right? So the less hops you have between your application server and database server, low latency, that is going to be critical. 1 gigabit is pretty much a must, right? If you can get 10 gigabits, that's good, right? Especially if you use some need backups or need to do a quick restore, right? Which is very heavy on network, and bonding and multipath for availability can be good choices. For operating system, in MySQL, Linux is more used by far, most commonly. Server-grade operating system, right? So, I mean, I would not like, for example, to run MySQL in production on Fedora, right? With no disrespect, right? Because I think you really care about your database, and often you don't want a quick change, right, in the operating system. You want it relatively recent, especially if you're running the recent hardware. For example, there is a lot of great improvement for solid-state storage support, right? And well, support MySQL well. Operation tuning, system tunings. Now, I would say Linux is pretty good by default for majority workloads, right? So if you take the Linux with no kind of tuning, put MySQL next, you will get quite decent. Of course, the guys like Facebook who has it need to squeeze like last few percent, right, and operate like a huge scale. They tune certain things, but it's not as needed. File system, I would say ext4 and XFS are good for MySQL in Linux, and yeah, there is also I did in our presentation of this. MySQL versions. New versions typically have a better performance. They often scale better, have a better optimizer, right, as well. But do expect some regressions. So every new version comes out at least first few months, and often kind of forever. There are certain things which run slower on the new version than on the old one. That's just life, something to deal with that. MySQL configuration. Now, for MySQL configuration, I will say completely opposite. You do not want to run with defaults, because MySQL defaults are bad, right? There are more details here, but also do not obsess with tunings. One thing I know with some people, they see, oh my gosh, MySQL has more than 400 variable tunables that you can play with, right? And then you can spend probably a year experimenting with various combinations and so on and so forth, right? Well, don't do that. If you have probably 10 of them, right, that will get you almost all the way there for majority of workloads, right? And that is kind of I wanted to kind of put the most important variables you want to examine on a single slide, right? You can just enter them in Google and find stuff how to tune it. Okay, Now, let me talk a bit about the tools and the process, right? So when we talk about the working with the database and optimizing, there are kind of two parts, right? One is there is developers who needs to be trained not to be thoughtless about performance. And then there's also developers operations guys who need to be able to catch the problems, right, and go and educate developers about catching those things, as well as making sure what they in operations validate the changes they implement, because hardware changes, configuration, different versions of operating system in MySQL can cause problems, and sometimes in unpredictable ways. I've seen so many times when operations would think that they're upgrading hardware, for example, but there is something like little things you change in configuration, and actually new hardware works slower than the old one, right? I had to validate it. Now, interesting in this case is what we say about the database run queries, right? And whatever changes you do, MySQL version, hardware changes, configuration, if something is going bad, then you will see that in the queries. And so what that means is, from best for operations guys, both for catching bad queries from development or to manage change control, is to look at the query performance over time. There are a number of tools, right, out there, like PT Query Digest from Performance to Percona Toolkit is an open source command line tool you can use. You can use MySQL Enterprise Monitor, Mongo, Vivid Cortex, Percona Cloud tools. These are not open source. Some of them, like Percona Cloud tools, are free. I will have to pay for. So so what you have here with Percona Cloud tools is a hosted solution, so you can analyze query performance over time. We would gather information from queries from various servers and operating system metrics, as well as configuration, and plot it over time. We capture with 1 second resolution, right? So it becomes pretty helpful, right? And can go beyond just measuring the averages, right? Which I mentioned may not be a good idea. So this is, for example, what you get as a query profile. And in this case, we can see, hey, what this select was done so many times, right? And it contributes so much load on the system. There is so much total time, and so on and so forth. You can pick the queries you're interested in and the range, and then look at more details. This page is a server summary, right, which looks at all the queries on the server, which I think is quite handy in which case. Like, one is I look at this stuff, right? The 95% query response time was 0.5 millisecond. This means that in general, this server is performing quite well, right? There may be some of the outliers query which are slow, but overall, it's not bad. Another, I think, interesting thing is rows sent and rows examined. Remember, I was mentioned to look at that. In this case, there is just 1.5 times difference between queries sent and queries examined. That means that from this standpoint, the system is optimized reasonably well, right? And I can actually spend 20 minutes just talking to how much stuff you can get from this page alone, but I don't have a lot of time. Now, we can drill down in the graph for different things. Like, for example, what do you guys think here, right? This is amount of reads which have been happening on the disk, right, on the server. Well, these are actual spikes which have been backups, right? I mean, it's almost always spreads in memory, but then logical backups comes and does a lot of I/O, right? Response time stability. Remember, guys, I mentioned you what backups may impact response time, and they do here, right? So we can see what those backups actually increase our average response time in this case. In this case, it's not really dramatically, right? But in some other cases, you would see much more severe spikes. So Yes, so the query information. Yes, this is an interesting thing, right? Is graphing the change, and I think that can be very valuable to show wherever that's developers, boss, how changes can impact something, right? So in this case, we actually had a table which didn't have a proper index, and it was getting larger and larger, right? So you see, so over time, we have query was taking more and more time to run, right? Then finally somebody noticed that and then added the index, right? And we get the query performance dramatically improved. Another thing what we focused on is things how we can tag, review, and comment the queries, right? So one thing what we found is what kind of workflow flow, right? As an operations guys, we often would notice the queries, and you need to put a comment and say, hey, this query is bad, right? And then making sure what developers actually fix that, and right, and then it's going to resolve. It's good if a system supports something like that, so you don't well have to just maintain that somewhere outside, right? Or you may mark, oh, this query needs to be eliminated, and you want to make sure what it's actually gone. It's not pop-ups 3 months later because somebody, you know, uncommented their own code, right, or something like that. Yes, live explain. I will skip that for a second. Oh, other stuff what we have connected that with Percona server summary and MySQL summary, so we can actually see from a web interface server statistics. We use that in consulting a lot because that's very helpful to get the overview of what's on the server. Addition to the query information, we have information about the metrics. Like in this case, there is a MySQL throughput, right? Queries a second. And there are much more things you can look. Some things like I/O time, number of MySQL threads running. That is a very good indicator for your database load. You can sort of zoom in and zoom out, right? In this case, as I'm showing, and one of those spikes. And what I also mentioned, we really want to provide information more in addition to the averages. So for example, in this case, we're looking at the throughput, right? And what is and this essentially shows us the range between 5 and 95 percentile. In the normal case, when the system is not loaded, every second it has approximately the same value of queries it processed, right? It's pretty narrow. In this case, as something happens, right, database overloads or something like that, we can see what it's not only the throughput falls and then kind of recovers, but you can also see what there seems to be some stalls happening because there are some seconds when there is a very small number of queries which actually have been completed. Right. Okay. To sum it up, right? If you look at the performance optimization, A, it's application performance, what matters. Focus on that. B, right tools for right job. I mean, MySQL is only one of the database out there. C, right? You want to see what queries on MySQL is running, and that is what is really a great indicator what you want to optimize for. And if those queries, you want to reduce number of queries, reduce number of data they return, right, to optimize them. See how you can tune them so they can do less work and do that work more effectively, right? This is kind of from bird's eye view how you can approach MySQL performance optimization. And that's it. Thank you, guys. Okay, any questions? Yes.
Can you go back to the slide where you had which 16th of June?
Oh, okay, you want to... Yeah, okay. That's my take too.
Fedora is not optimized for one thing. It's more general than just database. So I can understand why you don't like Fedora.
Well, I mean, it's not like I don't like Fedora. I specifically believe that for a lot of case you are looking for mature server side operation system, if not a lot of change. Yeah.
I can afford to run Fedora as a personal, for my personal use. But if I had to run a company with it, I would not want to do that.
Okay. Any other questions? Okay, no questions.
We're still dumbfounded.
Okay. Well, okay. Okay, guys, then anyway.
Your customers rely on your website or application. If it's slow or non-responsive, it infuriates your users and costs you money. Keeping your business-critical systems humming along requires insight into what they're doing. Your system metrics tell stories that can reveal performance bottlenecks, resource limitations, and other problems. But how do you keep an eye on all of your system's performance metrics in real time and record this data for later analysis? Enter Longview, the new way to see what's really going on under the hood. The Longview dashboard lets you visualize the status of all your systems, providing you with a bird's-eye view of your entire fleet. You can sort by CPU, memory, swap, processes load, and network usage. Click a specific system to access its individual dashboard, then click and drag to zoom in on choke points and get more detail. Comprehensive network data, including inbound and outbound traffic, is available on the Network tab, and disk writes and free space on the Disks tab, while the Process Explorer displays usage statistics for individual processes. The System Info tab shows listening services, active connections, and available updates. Adding Longview to a system is easy. Just click the button, copy the one-line installation command, then run the command on your Linux system to complete the process. The agent will begin collecting data and sending it to Longview. Then the graphs start rolling. Use Longview to gain visibility into your servers, so when your website or app heats up, it stays up.
Citrix Zen Server gives you everything you need to integrate, manage, and automate a virtual data center, all on an enterprise-class, cloud-proven virtual platform, and at a third of the cost of other solutions. But why even bother with virtualizing your server infrastructure in the first place? Well, let's say you have a traditional one-server-to-one application architecture, but you're running out of resources and performance is suffering. Once you order new server hardware, you'll wait for delivery. Configure it. Install your business application. Stage and test the server. And finally, add it to your production farm. If you've been through this process before, you know it can take weeks or even months. You also know it's a manually intensive process that will burden your team every time you outgrow your current setup. With a virtual server solution, you could accomplish all of that in less than half a day. Server virtualization software separates the OS and application from the underlying server hardware. And with multiple virtual machines on a single server, you can use each of them to run different OSs and applications. This makes it possible to move your virtual machines from one piece of hardware to another whenever you want, to maximize utilization, simplify maintenance, or recover from a hardware failure, and without slowing down your applications or users. Clearly, server virtualization provides big benefits, and Citrix Zen Server provides even more. Since it's built on an open platform, Zen Server plays well with your existing hardware, storage systems, and IT management software, as well as with the industry's leading cloud service providers. Best of all, you can get started by downloading a fully functional, production-ready version of Zen Server for free. After a 10-minute installation process, you'll see how easy it is to start virtualizing your workloads and automating your IT management processes. And when you're ready for a richer set of management tools, just upgrade to one of the premium editions of Zen Server. So whether you're interested in virtualizing servers for the first time, expanding your server virtualization footprint, or moving server workloads to the cloud, download and install Zen Server today and see how it can help you simplify your IT environment. Citrix Zen Server. Do more. Don't spend more.